All right, so previously we talked about the process of atomization, and this was how a basically compound gets presented into the AA, and a little bit about the process that has to happen before the AA can actually measure it itself. We'll talk more about this process a little bit later on, but that is a term that we need to present very early, so that way when we get to that point, you'll be very familiar with it. So last time we ended the video and we said that there's going to be some important pieces and parts that we're going to have to talk about when it concerns the AA instrument. And I need to list these pieces and parts for you now. So the very first one is going to be a proper light source. If we're talking about the AA instrument, it requires a light bulb. And the AA instrument is what we'll focus on throughout the entire lecture series. However, no light source is needed if we're talking about the process of atomic emission. That is something completely different. We're looking at how the light is emitted by the atom that's excited. In atomic absorption, we're looking at how the atom is absorbing the light from a light bulb. So AA is what we focus on. That's why we talk about light sources. But please keep in mind that if we're working with atomic emission, there's no light source required. Number two, we're going to have to talk about the burner. The burner or the flame is where the sample is atomized. And this, excuse me, and the settings around the burner and the flame are very important for that reason. Everything really relies on the sample getting atomized. And if the burner and the flame cannot do the job the proper way, then we're not going to get proper results. So we have to pay attention to those or that area at least. They both happen in the same spot. Number three is something that we call a monochromator. Mono, of course, means one, and chroma means color. So what the monochromator does is what it does in all spectrometers is that it picks out one wavelength at a time, and it sends that one wavelength to the detector. So we'll talk more detail about it when that time comes. But if you've already seen a monochromator in other instruments that we've talked about in the class, then this monochromator is actually no different. And then finally, we see a detector. Again, if you're taking this as part of the course, this detector is the same detector as used in all of the other spectrophotometers. There's no difference here. It's set up the same way, it works the same way, it sees the same thing, and it relays the signal to the software in the same fashion. So number three and number four are going to be repeats. Number one and two are going to be new items for everyone, no matter what your background's going to be. So we'll talk about each one of these. We'll talk about the good things and the bad things and the things to watch out for while you'll go through this process. How do all of the pieces and components hook up with each other? All right, well, there's some schematics that we can draw out, and I'll draw kind of the basic one first. So in the beginning, we have a light source. That's how we start off all of our schematics for our spectrometer. And this light source houses a light bulb. All right. And the light bulb basically goes through the flame. And the flame is going to be here. Now, the flame has my sample. Where did my sample come from? Well, my sample came from a beaker that I probably have sitting down below. So I'm just going to put my sample is here. And that sample is sucked up through the atomizer, which is really part of the burner, but I'm going to draw it separately here. And the atomizer goes into the flame. Right? I want to make that presence known because I don't want you to take advantage of it. So the atomizer has to separate, get ready for the sample to be presented into the flame but the atomizer and the burner is kind of made together in a way. So we'll talk about those two as well, but again, we draw those over to the side to let you know that that's coming from a different avenue or different route. Finally, after the flame, that's where the monochromator comes into play. It helps my detector see only one thing only, and that's it, so monochromator. And then the detector sees what's presented to it. So there's my detector. And then if we want it to, the detector can go into a CPU unit, some kind of recording device, some type of software system, some type of computer that allows the operation of the machine itself. All right. Okay, so if you look in the PowerPoint slides that will become available, this is what you will see, and it's drawn a little bit better than mine. I mean, I'm no artist. I can't even hardly write sometimes, but as far as drawing, that's even worse than writing. So here are the pieces and parts and how they align with each other. This is what we just basically drew. However, another schematic is something that looks like this. And what you've noticed is that they've not drawn the way the sample gets into the machine. They've listed the light source, they've listed the atomized sample in the flame. So they've left off those two pieces here to the side. They've left off the atomizer and they've left off the sample because they just probably assume that you know how the sample gets into the machine in the first place. Then the monochromator, then the detector, then the computer readout. Finally, here's another one. This is very similar again. Here we have a light source, and this is almost like a double beam. We have a reference beam that gets shut off in the back, and allows the machine to tear itself out. And then we have the sample or the light source that goes through the burner and then into the monochromator and into the detector. Notice it leaves off where the sample gets inserted into the machine. So once again, it leaves the atomizer and it leaves the sample off of the diagram. But what this diagram focuses on is a splitter, or what we call chopper, like we've seen in other pieces of equipment before if you're in the course. But this chopper takes the beam and divides it up into two pieces. A reference beam up here at the top and a beam that goes through the burner down here below. All right. Okay, so the first piece that we're going to talk about in detail is the light source. And we're going to talk about this in the next video because I want to really take my time and talk about the light bulb and how it's made and how it does its job and the things to watch out for when you put the bulb into the machine or when you choose a bulb to use for the machine. So keep in touch. Don't be a stranger. If you've got questions, send me an email, give me a call. I'm here to help, not here to fail.